Hey everyone, so we spent quite a bit of time this week talking about and looking at histograms. Mark Hansen was kind enough to come in and share with us some insight about data gathering and data analysis, and one of the big features that we looked at are these histograms, sort of a variation on a bar plot. And so we're just going to take a little time to go over histograms, sort of how we would construct them, what kind of things that they can tell us, and before we move into the topics for next week. So what I have open here is this same report file that we worked with earlier in the week. You'll notice that I have it open in OpenOffice, even though it's technically an Excel document. You're welcome to use whichever. I will say that when I've been trying to open this in Excel, it's actually taking a lot longer than an OpenOffice, so I'm with OpenOffice for now. So sort of to be mindful of what we were looking at, and that what we could do is take a look at the high and low prices, or maybe just the high prices, for some of our fruits and vegetables, and use as an example for how we might build a histogram and sort of analyze this data, see what we can learn about it. So I am just going to start by creating a new spreadsheet here, and I'm just going to take all of the rows of apples data, right? We want to compare apples to apples in this case. Ha ha, pun. And so I'm just going to copy these rows and paste them into a new spreadsheet. For my own sake, I'm also going to copy the header row. It's always a good idea. I'm going to insert this row and then I can paste. Okay, so this just gives me a good way to get a handle on what exactly I'm looking at. So I'm also going to go ahead, and these are just a few tricks for those of you who aren't familiar. I'm going to go ahead and hide some extra columns here that maybe I don't think I need right now. And I'm just going to focus on this low and high price. Now, my first thought with this is actually just to go and make a plot of the high price of my data. And let me move this window a little bit so you guys can see. Hopefully you can see the top there. So if I'm in Excel, I have this data option, and so I'm going to choose data. What I have is I have this little shortcut here that has chart, right? It's a little chart wizard. So it seems like a pretty decent thing to do, except when I open this up, what I see is, oh gosh, all these prices are all over the place. I guess they're organized. It appears that they're organized by row, which doesn't seem to me to be, now that I think about it, it's not really what I want to do. Of course, what I really want to do is I want to sort my data before I start making a chart with it. So I'm going to go back over here, highlight all my rows again. I'm doing that by, actually, sorry, not the rows. Let me do the rows. I'm going to highlight everything, and then I'm going to go to this data window and I'm going to choose sort, and it's going to say what column do you want to sort on. I'm going to choose J because that's my high price column, and let's see what we get from that. So I hit OK. You'll notice it has unfortunately thrown my label column out of whack here, but now that I have everything sorted, this seems like a reasonable thing to chart. So now I'm going to go back, make another chart on this, and now it looks like everything is, in the right order, but it doesn't look anything like the histograms that we were looking at in class. And so I was trying to think about why this was. And what I realize is that one of the things that we may have glossed over a little bit in sort of the practical creation of histograms, right, is that in this case, in the case of my data here, what I'm looking at is every row is one instance in which the price of apples was measured, right? So to go back to the examples we used in class, every row is kind of like a single coin toss. And if you remember, what we plotted when we saw that histogram was actually the number of times a particular value came up in that coin toss, right? So instead of having an individual bar for each reading, right? So in this case, each row I've got, whatever its value is, 35 X number of times, right, running across. What I actually want to do is I just want the digit number of the number of times that 35 occurs in this list. So actually, to make my histogram, I need to do a little bit of manipulation here. What I really need to know is how many of these rows have each of these given values. And to do that, I'm going to use a function in Excel, and we're going to see functions a few times. We're going to a lot of times actually in different places. We'll use them in Excel, we'll use them in lots of software and programming situations. But basically what a function is it's just sort of a little set of steps that the computer performs over and over, and that you use this name in order to access it. So when I'm in Excel, if I start in a cell with if I put an equals sign, that's basically a little flag to Excel saying, hey, what's coming next is not text, it's actually the name of a function. I want you to do some work on the stuff that I'm going to give you. So in this case, the name of the function is count. Now, you see how this little window pops up? If I were to just put in count, right? Well, what do I have? I just have a cell with the word count in it. But if I say equal count, right, and then I have this open parentheses, right? The open parentheses is a programming way of saying, do these steps, do your process on the things I'm about to hand to you, on the things I'm about to give you. We call those arguments to the function. So what I can do is actually just select these rows, and I do get this little highlight, but of course I want to make sure that I hang on to that value. And so what it's doing is just saying how many things are there in here. So this is a little bit of a manual process, right? Obviously that one I could have written myself. So I'm just going to go through and do all the 20s and then all the 22s. And so what I'm doing now is it's as though I'm counting the number of trials of that coin toss. I'm counting the number of instances in which each, the number of times each of these prices appears. So this is going to take a minute, and I do encourage you guys to follow along at home. Oops, got a little volume issue going on. Oops. Oh. So that's actually a good example. So if you pass some information to a formula and it doesn't know what you're talking about, you get that weird pound question mark name thing going on. It's nothing to be concerned about. It just means that the computer doesn't understand what you're asking it to do. And so you need to go check that formula. So again, here we go. Count. Probably I'm going to show this to Mark and he's going to tell me there's a much faster way to do it. But I want you guys to understand, you know, sort of what these approaches can do. In fact, we're going to look at another piece of software which is much less manual than this. But I personally find that it's good to know how to do things more than one way, because you never know what kind of resources you're going to have, and also it really helps solidify what, you know, sort of what's going on when you do this sort of thing. So we're almost done here, I think. Maybe not. Right, receiver experts. Oh, by the way, so for those of you who are wondering, when I'm selecting these multiple rows, right, what I'm doing is I'm just using the arrow keys to go over into the next cell, and then I'm holding down the shift key as I scroll down, and in doing that it sort of holds on to the reference. Just a handy way. A lot of people you'll find who, you see this a lot with people who do creative work as well. They get really skilled with keyboard shortcuts because it's much faster. So now what I want to do is I'm going to go ahead on and I'm just going to take these two columns of data, right? So basically these two columns of data are my high price, right? The high price reading for that variety of apples, and then the count, the number of times that particular price was recorded in this particular instance, in this particular day. So I'm going to swap to a new sheet over here and paste my data in. Now something's going to happen if I wanted to get rid of, if I were to get rid of these two columns, right? I only need the number 3 once for the number 16, right? The price 16 was recorded 3 times, so I just need 16 and then the count 3, right? Now I have a formula in there that's actually actively counting these rows. So what happens if I go ahead and delete these 2 rows? The count changes because now, in fact, there is only one row that has 16 in it. But since I want to freeze these values, I want to hang on to these values, what I'm going to do is I'm going to copy these and I'm going to use paste special. I can do it directly over the formula. If I were in Excel, I would see something called paste values. In this case, It defaults to paste all, but I'm going to say, you know what, don't paste the formula. And that way it's just going to paste actually the number. Whoops. Hopefully it will. Sorry. Let's do copy, paste special. Now I want numbers but not formulas. Yes, there we go. And now we see that this 3 is really a 3 instead of that formula that says count of the adjacent columns. So now if I go through and delete these rows, what I get is a nice, concise data set, summary set of how many times each of these prices was recorded for my particular data set. And that is, this is actually the data. These counts are actually the things that we would turn into the histogram. So it's a step that we don't always think about, and sometimes I find that when I get to a data set, I'm like, wait, what do I do first? And you want to make sure that you're doing this count, because that's what a histogram is. It's a count of the number of instances or the number of times that a particular reading was observed. So I'm going to finish with this, and we can sort of see already, right? Like there are certain values that seem to sort of pop out already as very common. Like we've got 25 on the price 35, which of course is another question, which is what are the units of that? So I'm going to go ahead and delete. Do my last deleting. Okay, now I can use my charting mechanism, right, and highlight my data set. I'm going to click on the chart here. Now you see its default again is it wants to do something weird. It wants to make this sort of double bar chart. And it's because of that thing we noticed with the student data from UCLA, which is that it's looking at column A right here and it's saying, oh, this is a number, so clearly you want to chart that. And we're just going to organize it by row. But of course we realize that even though this looks like a number, it's actually it's a label, right? For us, it's a label. It's the price of the apples. So when I go to data range here, it says data series and columns, which is correct. But what I'm going to do is label first column as label. And then I see something that looks a lot more familiar, much more similar to what we saw in class, right? Now we don't have the same level of control over, say, how many bars we get. In this case, it's giving us just 1 bar per reading, which is okay. It's all of our data in this case. We couldn't break it up any further. But it's interesting. What I see here, right, is a little bit of what we saw with that sort of what we call bimodal distribution, right? There's 2 bumps. Right, there's this bump here that obviously has these sort of gaps on either side of it, which is kind of interesting. Not a lot of people doing 34 or 38, lots of them at 35. So we see this bump, but then we also see this bump down here. And one question that I had is, well, what is it that distinguishes between these 2 sets of data? What are, why the bump in one place and not in the other place? And I came back in and I said, okay, well, I've got these ones that are around 20 to 22, so just to make it visually, before I try to do anything like a mosaic plot or something fancy like that, I shouldn't say fancy, it's very useful and I'm sure will not be difficult. And then I'm going to look at all the ones that are 35. Here we are. And I'm going to highlight them in a different color. And I'm just going to see, because I didn't look at, variety or grade or anything like that when I was doing this. I didn't sort of sub-select for any of those things ahead of time. And I'm going to see what kind of differences I can see. Now, I sort of scanned through the location, the source location. I thought maybe the cheaper apples were more local, but I got quite a few from Washington and California over here. And then I came over here and I started to see this column. And what I see is that the yellows have this FR appear thing going on. And the blue ones either don't have anything or they have this fine appearance. So I don't have any idea what that means. So what do? I turn to my good friend Google. And I go to Google and I say, FR appear apples. And one of the things, there's a lot of stuff that comes up. None of them seem to offer a destination, but this does seem to be a code that comes up every once in a while. Well, fortunately, there's still human beings in the world. And so there's this phone number, and I called up this number and got a very nice woman named Kim who said, oh, fair appearance means that they're not as good looking as the other ones. And so that might be one reason why these are a little bit lower cost right now. So in the next video, we're going to come back when we talk about more of mean, median, distribution, all that stuff. But for now, sort of first shot at doing a histogram with some of our fruit and vegetable data. Bye.